Hi. Happy Monday. I forgot what day it was. How are all of you doing? Yeah, let's see. Got a lot of stuff this weekend. What did I do? I ended up, let me put this in stream notes first off. Well, start looking at stuff. Ooh, actually, wait. How do I just realized, how do you hide your social thing? There we go. In BattleNet. Yeah, okay, here we go. All the poor souls that actually know me and are BattleNet friends with me, I'm sorry. But yeah, let's see, this weekend, catching up. So, this weekend, I went to my mom's place and went to go fix my brother's car and finally finished. Hey, P3, how are you doing? You are sleepy. Hi, Sleepy. Where's P3? So a while ago, I was changing the oil in my brother's car, and there was an issue with the drain plug on it. So I took it out, and I was trying to put it back in, and the thread stripped, and I was like, oh no. And I'm trying to fix it and all this kind of stuff. It didn't really ever go back in. It was really weird. And then eventually, after doing a few tricks, I found out the hard way that what actually happened was that someone who previously changed the oil in my brother's car fucked up the threads really bad, and then they installed a helicoil. And the helicoil basically just broke when I was trying to put the thread back in, or the bolt back in, and it was really weird. I think they actually stripped the thread on the bolt in addition to destroying the thread in the oil pan. So it's just okay, so everything's broken. I'd bought a new drain pan plug last time, and it didn't work because without the helicoil, the threads were totally messed up. So finally was able to order a replacement helicoil installation kit, and I was like, okay, let me see if I can just install a new helicoil and basically just reuse everything that's there, because otherwise I have to either drill out a bigger hole, which is concerning, or long-term fix would be just to replace the oil pan. So anyway, yeah, I got a new helicoil kit and installed a new helicoil, and it worked. So yeah, that's a huge pressure relief for, I guess, my brother and I felt really bad that it wasn't working. So yeah, it's working. And then the other one was there was a weird clicking on our old SUV after I fixed some stuff on it. And I went back and I got a new mechanic stethoscope, and I was trying to figure out what was causing the clicking. And as I was poking around with it, the clicking went away, and I was just is this wishful thinking? And I had my family listen to it, and they're like, I don't hear what are you worried about? I'm like, you don't hear a periodic clicking? It used to be a click, 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 click. And they're like, no. I was like, oh, cool. So I guess this car also works. So yeah, I can like do some additional service on it, like swap out all the fluids. It really needs all the fluids exchanged. I should probably get a new serpentine belt. And I think there's something else. Spark plugs. Probably get new spark plugs too. But yeah, for now it looks like it's fine. So we went from how many cars did we have? We had 4. My car, my Miata, my brother's car, the old SUV, and our old sedan. We went from 2 working cars to now 4 working cars, three-ish working cars. My parents' sedan needs some work. So yeah, it's pretty exciting to have all the cars working again. Also, like, opens up the ability to do some other stuff, fixing cars. Yeah. I think the plan for today is I'm going to do a little bit of D4. I'm sorry I'm late. I was trying to catch up on some stuff for this coming weekend. And I was trying to hit my step target, like minimum step target of 15,000 steps. So yeah, let's do a little Helltide or something and then go back into coding. Yeah, during the day, I was reading the Vespa docs on how they integrated BGE M3 models into their like stack, and it looks like that's a better thing to follow than the stuff from Pinecone, because like I mean, I guess if I wanted to use Pinecone, I could use that, but I don't know. I wanted to use BGM3. And Vespa actually had docs specifically talking about how they integrated that model from Hugging Face / Beijing University. So I'm kind of excited. Like, I tried it on some sample, what's it called? Sample recipes in my database, and it looked like it was working fine. So it was really fast. Like, I think 50 recipes doing the ingredients and the steps. The total transformation took like, I think like on the order of like seconds. So I'm just like, okay, maybe I can do this with everything. And there is a lot of lag. Oh well, we're just gonna have to roll with it. Legion event in 6 minutes, or this Helltide expires in 27 minutes. I'm gonna do the Helltide. Yeah, okay, cool. Man, I wish I had more money for a lot of reasons, but like it'd be cool to have a 4090 to do like AI stuff and also stream. But I guess I could, in theory, it might be better to just like do I think it's like NDI thing, and just like have a second computer process all the streaming stuff. Oh. All right. Is this too loud? Maybe it's not too loud, but it is very laggy. How can I change the resolution? It's a slideshow, isn't it? I'm like seeing my peripheral vision. Does the stream look okay? And it looks kind of terrible. And I'm just like, all right, well, I don't think y'all are coming here for my Diablo 4 streams anyway, so hopefully it'll be okay once we get to oh boy. Oh, sick. I got her just in time for the Blood Maiden to die, and I got credit for it. That's amazing. Holy shit, they're all very strong. How are these people so strong? What the hell? I'm not even, I can't even hit anything to generate spirit. They're just killing everything. That's really funny. Reminds me, I was supposed to actually go tweak my gear. So I was talking about this game with my brother the other day, and he does like a shit ton of damage. And one of the things that we realized was like, I've been really lax in upgrading my items, like my actual equipped items. And he was like, you know, if you just upgrade all of those, like your damage will probably, like, that's the easiest way to increase all of your item power. And I just, like, lost track of doing it, just because, like, it was just easier to keep farming stuff. And I never really paid attention to, like, okay, what are the aspects and affixes I should actually, or what are the affixes I want, and how can I maybe farm for those better? And instead, I'm just like, okay, I'll just keep chasing enemies, and probably would have been just fine not doing that. Let's see, Alt is the key. Sheesh.
I cannot carry anymore. My bags are full.
See, I don't know why. Let me see if there's a way I can like make this not lag so much. No, it's gonna lag. I tried. All right. Although this does make me wonder, like, is my when I'm coding, is it this laggy? Because this is like really bad. uh, Okay, I think this is an upgrade. No, I have this maxed out already. Okay, cool. Save that one. I'll transfer that one. Not transfer. I'm so used to Pokemon Go lingo. Ooh, max. Okay, cool. That one I'm gonna salvage. Cool. Alright, where is a stash? Stash. Put all the stuff in there. Which I should have done to begin with. Okay. Map. Oh!
Not while I'm in town.
Okay, don't summon anything, because I'm not strong enough to take all those things by myself. Good dog. Okay, go back to the tree. This is a very efficient hell tide. Oh, fuck. Go back to the tree. Or something else spawns. 378. Okay, I can find an orange. This is not the tree.
It is done.
Chaos. Hmm.
Come back if you need the forge.
Yeah, how are all of you doing? Managing with my slideshow stream? I didn't think D4. I don't know what it is. Like, it feels like sometimes D4 really doesn't. Is my computer's fine streaming D4, and then other times it's like, what the hell? Like, even now it's kind of slow just playing. I don't know what's going on. I should have maybe just restarted my computer before stream. You would think I would learn to do that, since it seems to fix almost every issue. Although, I'm discovering like a new thing with my computer that it likes to do is, why are there no chests here? Oh my, new thing it's been doing is it doesn't, boot. It will freeze on boot or just freeze after it's like been running for a while, and it's just like, oh my god. So I don't know, something might be going on with my computer and maybe I have to fix it or something. Like, it froze when it was booting up, and then the BIOS actually had to do like a self-repair earlier. So yeah. Here I am again, helping the farm blood maiden. Actually, I'm gonna, while they're doing that, because they don't really need my help, I'll go here.
Must wait a moment.
Hey, another one.
Well done.
Alright, where are we headed? Oh my god.
I need more spirits.
Oh, there was a loot goblin here and I missed it. Ah.
You there, please help.
How am I frozen? Come on. Alright.
Wouldn't have made it without you. Wouldn't have made it without you. Will you help me, stranger?
You were the answer to my prayers.
Alright, how many more cages are here? One more, it says.
Will you help me, stranger?
I do not have enough spirits.
All too easy. Cool. Alright, so I got Grim Favor from that. Let's go to the chest. Oh, it's right here. It's easy. Ooh, wow, that's a lot. Ooh, that's also a lot. I got feared. Okay. Oh, Hellborn? Come on. Ah! Alright, I didn't even get to loot all the stuff. Alright, is there another orange chest in here, or is there... Alright, Doomslayers. Find the corpse. Tortured Gift of Protection. Find the corpse. Okay, there's one down there. And somehow a legendary is waiting for me? Okay, cool. How much time do I got in this hell time? Oh, Jesus. Not a lot. Let's make our way down there real fast. Oh, Doomsayer.
Light, show me mercy.
Cool. Oh, sorry. That was my own dog. Good dog. Sorry. Why is there so much gold just on... Where?
I must wait a moment.
Get me on my horse. I need to go to the stupid chest. God damn it. Come on, come on, come on, come on, come on. 54 seconds. I can make it. I can totally make it. $275? Come on.
I do not have those spirits.
4 more. 3 more. No, come on. Oh, you only point one. Post working hard. Yeah, I don't know. I've been trying to fix that. I don't know what's going on. Damn it. How are you doing, Hithouse? I don't know how I have loot from all the way down here. I haven't been here. It sucks. I didn't get that one. I got 275 cinders like literally right when the Helltide ended. Legion event in 4 minutes. Okay, let's do the Legion event and then we'll call it for... Voice works a lot better, but even is running on butterfly. Oh, wow. That's... Okay, is this better? Like, this looks like it's not lagging anymore. But, never mind. Once D4 does anything, it just kind of... Okay, well... We'll be done with this pretty soon, I think. Hopefully the Legion event only takes like 12 seconds like they used to. Oh god. Where the hell did all these people come from? event. Should almost be at the Legion event. Alright, is this any better? No. What happens if I do this? That's slightly better. I don't know why that's slightly better. If I make it the active thing, is it better? Oh no, it's terrible. What is going on? Streamers all focused on the game, goes to prove the game is good. What if I do... This is the same... Hold on. I don't know what I did with my scenes, but this is not different. Alright. I don't know, maybe... I don't know if it helps it just... I'll just talk while I'm playing D4, I guess. Yeah, hit test. I don't know if you heard me say earlier, but I was messing around with BGM3 embeddings, and it turns out like it's pretty easy to use them with like with the library. It's like flag embedding. I was trying to figure out how to use this. The data structure returns is this like massive dictionary, depending on I guess like how many documents you're processing. And I was trying to figure out how to actually use them more efficiently, and then I realized that like Vespa actually, I guess like first party, first class citizen or whatever, BGM3. So they have like example notebooks and stuff that are like, oh, this is how you would use, like one, here's how you'd take the model in and then convert it to an ONNX if you need to. And then here's how you would integrate it and deploy it on Vespa Cloud. I still kind of think that like their documentation feels a little weird. It like jumps straight into the like, here's how you deploy it into Vespa Cloud. And if you want to get it running in a local Docker container, here's what you can do. Oh shit, Helltide is in the Legion event? My lips are chapped. I definitely just tasted blood. Sorry, I forgot to change the scene back. So, welcome back to my Diablo 4 slideshow.
I must wait a moment. ready yet.
All right. Oh, you're immune. Okay. This is way better now, full FPS, no audio breaking. Do you get rebuffering every 15 seconds when you get to see about 1/3 of the unimportant screen? Sheesh. They're so strong. Alright, maybe I can, like, really quickly harvest, redeem, like, an orange chest, because it kind of got ripped off last time.
Hello.
Kill 300 demons. That's why we're playing Diablo. Oh, you didn't catch all that? Oh, that's okay. I'll probably... Oh god, it's a hell of a one.
I must wait a moment. I'm not ready yet.
Oh, no, 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 no.
Wait a moment.
Oh my god! I hate being frozen. It's the worst. Okay, well...
No, no, no!
gratitude.
Thank you.
Oh, wow. Holy crap.
I must wait a moment. I must wait a moment.
All right. That was a lot. Good dog. Okay. I can get one more orange thing. Right? Right? Oh god. Assisting Iron Wolves. Grab this protection shrine. Oh, why is there so much freaking lag? That was a helpful Doomsayer. Just giving me all legendaries, not even putting up a fight. That's cool. Another orange thing? Yeah, I don't know what's going on with my FPS. It's really bad. I can swap it to this, and it may not be as bad. It's still pretty bad. That fixed it before. Looks like that trick won't work anymore. Yeah, I have no idea what's going on. I feel like sometimes Diablo 4 just does this. I've noticed is like the performance just suddenly, especially when I'm streaming, just like goes into the crapper. And really, I feel like what I should have done was just restarted my computer before stream, but I didn't do that. So that's where we are. How are you doing, Terry? Ugh. What is this event I'm walking into? All right. Ugh. Ugh.
I'm not ready yet.
Alright, that is enough for one orange chest. I feel like that is a fair time to stop. And also, we're about to hit our ad break, so who knows? Maybe I can... Well, I need to call like 40 more demons. Please do not summon a Hellborn. You summoned a Hellborn. Blue. Why did I pick up a blue? Okay. Okay, we're good. We don't have to... Well, okay, let's kill a couple more demons and help a couple more, you know, because we're 2 out of 3 and we're so close. It seems a shame to stop now. We just won't go for another orange chest. We definitely can't do that. Good enough full sound, but 0.5 FPS. Awesome. I love it. You know, 2 steps forward, however many steps back. That's better than nothing, right? Okay, I need to help one more Iron Wolf group. These are not Iron Wolves. I just got suckered into fighting a bunch of stuff. What's up with this event is weird. Right, my inventory's full. I'm just trying to find some iron balls. Oh, hey, there's an altered Lilith? Sick. Okay, I totally didn't intend to get enough cinders to open another orange thing. Oh, sick. That was an Iron Wolf thing. Cool. Cool, cool, cool. Listen to chill hop while I'm playing. Yes, yeah. Because you know, eventually we're gonna go into actually doing data science stuff. I just started Pretzel and I just let it go. Watch. It'd be really funny if Pretzel was the thing that's like destroying my GPU right now. Would it be funny? Actually, probably not really, but you know, that'd be really wacky. Let me see.
Greetings. How shall I guide my hammer?
All right, I have enough. Oh, freaking tree. No, we'll do that later. Let's just get. Oh, hey, tech support. Dang, thanks for the sub. Thank you. How are you doing? How was your stream earlier today? We are focused on my face right now because I'm playing Diablo 4, and if I switch into it, it's gonna be awful. Actually, why don't we just... Yeah, thank you for the sub. Once we finish this stuff, we're going into data science, I promise. Oh my god, we have to go all the way there? Okay. No. Screw all of you. We're going to the chest. God damn it. Oh, thank you. Actually, I needed that random block of aberrant cinders to get this. It's funny. Cool. All right, back to the tree. No more D4. Ugh. When Doom Dark Ages is out, if I'm still streaming that, I'm gonna play Chill Hop while playing Doom.
It is done.
Ooh. Going through some cursed beautiful TypeScript on the stream. Oh, wait. Cursed beautiful. What is how huh? Ugh. Wait, undiscovered. What could be undiscovered? Oh, it's not in the game yet. Okay. Go back to me, and then exit Diablo 4. Hopefully the FPS goes freaking normal. And then we're gonna change into software and game dev. It's really hard to... Where in game dev? Okay, did my category change? Yeah. Okay, yeah. So, wow, look at that. Normal, fluid FPS. But yeah, let's see. What was it gonna do? Also, let me see. Should shout out tech support. Who's actually doing real streams now. As opposed to me doing fake data science streams with, or fake software engineering streams with Diablo 4. Why didn't that command go through? Okay. Oh, wait. That was from yesterday. Okay, will not Willy. Did I check your link above? Do you have all those settings already? Let me see. I did not see that link. What? Let's see. Stream. That's funny. Streaming Diablo 4 using a single computer can be challenging, but it's definitely possible with the right settings and optimizations. Here are some steps and settings to adjust in OBS. Okay, these are fine. Maybe not this one, because frickin' Xfinity. Let's see. Canvas resolution, monitor's native resolution is 1920 by 1080. Let's see, output should be 1280 by 720. I think that's what I have. Downscale to bilinear. Set to 30 FPS. I think these are what I have. Let me check. I can't change these while streaming. Okay, my output's at 1920 by 1080 because normally it's fine, right? When I'm doing like data science stuff, but if I'm playing D4, I guess it's not. I have NVENC. Let's see, CBR, advanced renderer. These all look. Match your monitors and lower it. Set to medium or low to reduce. Yeah, I should do that. Disable VSync. Cap the frame rate. Close unnecessary. Yeah. I think this is a big one. The disabling hardware acceleration. I think Opera like really annihilates the GPU. So that's probably what is causing my problem right now. Let me see. So yeah, and like, I've noticed when I open Opera, it's just like, wow, it's a huge mess. Let's see. D4 quite laggy. Hit house. Set this. Immediately after category changes, all FPS is never about Diablo. It's all about incorrect Twitch category. Yeah. We'll change it to, we'll just stay in software and game development, and then like as I'm like running through a hell title, I'll be like, yeah, so K means clustering, right? Am I right? Or like I'll just like let me see. What I'll do like while I'm playing D4 is I'll like read the AI news recap from the day before and just like be like, yeah, okay, so oh yeah, fucking Hellborn. Yeah, I'm outputting at 1080p right. Yeah. So if I output at 720, I feel like the code is going to be illegible because it's already like so like it feels not very sharp when I have it at 1080p, and then I'm blowing it up really huge. So I don't know what'll happen if I like output at 720, but I'm at like the same text and stuff, because like as it is now, it's like hard for me to read, and that the letters are huge, and I'm just like, I don't actually like reading letters this big. I just do it for stream, so that, you know, all of you can follow along and like rip me a new one for not being a very good software developer. Yeah, maybe this is like I'll play D4 and I'll have this like scrolling as I'm playing and just like trying to read along. I'm really curious actually, like Apple and AI stuff I never had on my radar. Like I heard that they had some AI stuff, and because they didn't really publish anything, it was just like, I have no idea what they're doing. And most of the stuff that they did was like, here's how to refactor your code to run on with full acceleration on Metal. And I was just like, that is honestly not very exciting to me, because it's like that really limits the amount of hardware that you can deploy your stuff to. Like it's cool that it's like you can figure out a way to maybe do better inference on device, but like they were advertising stuff of like we trained it faster using this stuff, and it's like, man, I don't think that's scalable, right? Because like Apple, I don't even think makes server hardware anymore. So all of a sudden you're just like, what are you trying to network together like a shit ton of MacBook Pros? It's really weird. Like, if I'm wrong about this, like, feel free to just tell me. But I kind of just had the impression it was like, this isn't, their AI optimization stuff wasn't as exciting as most of the other stuff. And then I feel like I was kind of surprised by their new product announcement. And they had just announced a bunch of AI stuff. And like, I don't know if even AI newsletter is like really excited about it. It's like, oh, okay, cool. Like this one, I'm not excited about because it's just like, oh, we directly hooked in the API. It's like, okay, cool, great, very good. And then this one I'm also not actually all that excited about because it turns out that I think like now that time has passed and people looked, I think people found out it's just like it's just running, it's like a window to Azure, so it's just like, okay, well then that's not maybe as cool. But like I didn't realize that they're doing they uploaded stuff to Hugging Face, and that they actually tried to talk about, let's see, Apple announced Apple a suite of generative AI features integrated. More quietly, they also offered a peek into its new model's performance and how they're trained and optimized. So like this I think is pretty cool because like how did they do it, right? Because like they're on device and in cloud and they're like very famously like not aligned with anything that would use CUDA. Find the needs to move more cautiously, invested heavily in its Siri voice assistant technology that outpaced. Since then, the famously secretive company has been perceived as falling behind big tech rivals to AI. Now its strategy on display, proprietary foundation models, LoRa to fine-tune them to specific tasks, emphasis on the user experience over raw productivity, judicious use of edge and cloud computing, and deals with other model makers, all wrapped up in substantial privacy protections. Okay. Imagine what FPS you would get with your dramatically underpowered Twitch partner status if your category would be hot tubs and hot money. Maybe not recently. I've been like a little lax on the dieting, so like I'm not as shredded as I could be. But yeah, I still this I don't know. So this part with the LoRa to fine tuning is like, is it that different? I thought that that's what people did. Like when I was reading stuff on Stable Diffusion, I saw a lot of things on LoRa, and I was like, oh, so that's just a way to like take a more general model and then have it like, instead of retraining the entire thing, you just have it do like a specific task. I was like, is that different from what other people have been doing? But I say this now and I'm realizing like, I have heard of people, they're just like, just take the biggest fucking model you have and throw it at every single task you have, and then it'll probably be good enough. And I don't know, that's one where I'm like, can you make it like smaller so we can actually have like on-device compute instead of sending like tons of stuff into requiring server compute for everything. So I don't know. Hidos, how do you feel about this? About like all the Apple AI development stuff? Chill. This is not chill. This is, man. Okay, we're gonna find some like, we're going to K-pop piano mixes or something. I don't know. This is like, can I swap my, I can't. Okay. We're going way more chill.
the puppies
Oh my
are
god, oh my god, oh my god. Skip this ad. I never would have expected for a chill hop radio station to be better for like D4 and what's it called? Doom. Okay. Let's get back to this. Actually, I wanted to, let's see. Visual morphology. Is this music? Solving vision tasks using simple photoreceptors instead of cameras. Instead of the standard solution of using common high-resolution camera, we solve vision tasks using a handful of simple 1x1 photoreceptor sensors. Video shows an agent equipped with 32 photoreceptors, so less than 1% of camera resolution, successfully navigating to a target ball in a novel scene. What the hell? Use a common high-resolution camera. Choose its placement on an agent based on human intuition. Extremely simple and well-designed visual sensors found throughout nature allow many organisms to perform diverse, complex behaviors. Motivated by these examples, we raise the following questions. How effective are simple visual sensors in solving vision tasks? What role does their design play in their effectiveness? Let's see. First, we demonstrate that just a few photoreceptors can be enough to solve many tasks, such as visual navigation and continuous control, with performance comparable to that of a high-resolution camera. Second, we show that the design of these simple visual sensors plays a crucial role in their ability to provide useful information and successfully solve these tasks. To find a well-performing design, we present a computational design optimization algorithm and evaluate its effectiveness across different tasks and domains, showing promising results. Finally, we perform a human survey to evaluate the effectiveness of intuitive designs devised manually by humans, showing that the computationally found design is among the best designs in class. How far can a simple eye go? Human, cat, goldfish. This is pretty cool. Part of me feels like I'm surprised that this hasn't been explored more, because like I feel like as a practical level, if you throw like a 4K camera towards one of these things, you're not really using all that resolution, right? Like I mean, a lot of the computer vision data I've been using is like or seen, like that I've personally used, not like reading all the research or whatever, but it felt like it was like not even HD. So it was kind of like, oh, so like, you know, Sony's like highest resolution camera is like what, 80 megapixels, and it's like you're not really using any of that. So it's kind of like, oh, cool. Let's see. Feel strongly about it. Makes you feel strong. Usually Apple makes everyone feel weak. Now they're playing a different game, and this is probably sneakier. Ooh, okay, cool. Chat watching streamer watch ads. Very meta. Well, it could be like those, have you seen those like the ads from like, what was it, the Philippines or Thailand, and they're basically just like dramas, and then they make you cry, right? So like, that would be quite a stream. It's like, chat, watch a streamer, watch emotional ads. But yeah, this is super cool. The other thing I was thinking about is like, with the human eye, like, it is like, you know, normally if your vision's healthy or whatever, you can probably see in a lot of detail. But like, I don't know, when I can still walk around my house and stuff if I'm not wearing my glasses, right? And most of the time I don't really bump into anything. I wouldn't drive that way because it's really dangerous, right? But if you're like walking around relatively slow, you can take your own time, then I guess like that is like a weird thing of like, I have less resolution. And it's like, huh, it's really cool. I feel like it's like one, like, holy crap. And two, I guess if you abstract think about it, it's kind of like, or step back and think about it, it's like, I guess this makes sense. I am curious, like, how much data does this cut down? And like, or I guess like speed. Let's see. Because if it means you can just do things, obviously you can do things like way cheaper, but like if there's a way to do things like possibly faster or something. Intelligent ensured the strong performance in optimized simulators. We conducted target navigation experiment in a real-world setting. We deployed a control policy using 64 PRs on a real robot, successfully navigating the target ball in an unknown room with no real-world training, relying solely on the low-resolution visual signal. Oh, that's so cool. Okay. I mean, this is a little too slow to do in real life, if you're like walking around, but like this is obviously it's just like a first try at this sort of thing and just showing like, hey, look what this can do. So it's super cool. My heart will be broken a little bit if it's like, hey, it turns out we're doing a retraction because we were using the robot camera the whole time and not the photoreceptors. But I'm trying to be like, okay, no, this is actually really cool. Let's see. Low resolution photoreceptors working as well as cameras. Well, performance is using close to camera performance in most cases. And it's performance kind of comparison to intuitive designs. I'm definitely just like skimming this. We demonstrated that extremely simple visual sensors like photoreceptors can solve. Okay. Mirror. Oh, I thought it was gonna say like it has trouble with mirrors, and I was like, oh, like a vampire. We showed that design optimizations of simple visual sensors is crucial for achieving performance comparable to more complex camera sensors. We propose a computational design optimization method to improve initial designs and find well-performing ones. Below, we discuss some limitations of our work, scope of the scenarios, vision tasks, and agents. We focused on active vision tasks primarily involving locomotion and typical robotic agents. Exploring other tasks and less typical scenarios, like a perceptual micro-robot for medical tasks, would better illustrate the limits and applicability of simple visual sensors. Makes sense? Besides PR sensor performance or photoreceptor, factors like the number of sensors, I forgot I can do this. I can look at the monitor, so it kind of looks like I'm looking at you. Production cost, power consumption, and physical size are crucial. Ignoring these aspects, similar to disregarding weight distribution in a square cube law, can lead to impractical solutions. Yeah, I guess because like they did they really have like 64 photoreceptors? Like how big of a device is that? I mean, well, actually it fit on the Roomba or whatever non-trademarked version of this is. I mean, that honestly, that looks like a webcam. That's not very big, and the webcam is probably the camera part. Let's see. Here's the most important news of yesterday. NumPy? Uh-oh. What happened? Anablebs is such a good name. Show the scenes above continuous control is very cool. They do show vision is better, but that tasks need very low res. They don't stop there, then go into designing a visual sensor. Ask self-learning systems options from further. I would like to see this in like a well, okay, I was gonna say I would like to see this in something like low stakes, like basically like doing a Roomba or whatever, but then it does make me wonder if it's like, oh, how much are they actually gonna record from that? Let's see. We considered simple robot morphologies using primitive shapes like boxes and cylinders, making it easier to parameterize the design space. More complex robots, such as soft robots, require a general method to parameterize their surfaces for design optimization. Improves initial designs to find well-performing ones, but as a local optimization method may get stuck in local optima. Okay. Let me scroll back up. Continuous control. DeepMind Control Suite provides a variety of continuous control tasks. Show the scenes above them is very cool. This one, right? Vision is better, but that has to need very low res. For each agent, we plot 50 trajectories from 2 episodes of unseen test scenes. The PR agent explores the scene as efficiently as the camera agent and achieves comparable performance. I'm trying to think of other ways we could apply this stuff. It is, I think it is really cool. Pure shallow transformer, camera shallow transformer, intelligent blind, the camera resonant 50. GPRS creates a 4x4 to outperform significantly an intelligent blind agent without a visual signal. PR agents match performance of the camera agent using the same shallow 3-layer transformer encoder as for PRs. While having visual signal bandwidth of only about 1% of that of a 128 by 128 camera sensor. That's really cool. Using the ResNet encoder, default choice in the literature, PR agents still perform reasonably well. Okay. This is, I'm very impressed. All right, NumPy 2.0 is, oh, hey. This has been over a year in the making. In addition to many new features, it contains breaking changes to the ABI as well as the Python and C APIs. Cool. It's likely that downstream packages and end-user code need to be adapted. Please verify whether your code works with the release candidate 2. Please see more for more details. This is... rough plugin. You should install... I don't know what rough is. What is rough? An extremely fast Python linter and code formatter written in Rust. God damn it. It is something I actually want. Feel like some startup founder is going to point to this and try to use the lowest quality sensors for high-risk context. Yeah, I agree that it's something I would worry about. And welcome in, Panda. How are you doing? Yeah, but hopefully, you know, what's this building GPT from scratch? Oh, yeah. So that is a video towards Andre Karpathy's class. We haven't started it today yet, but it's this lecture. So I forget which, I don't know. This might be the first one still of working on GPT because I think Andre has a few. I think even a few days ago, he said, like, we're going to build GPT-2. Let's see. Let's reproduce GPT-2. So I am on, it was like make more, and then it became GPT. And then I was, you know, I've been very slowly working through this. And then I was going to probably start this one on, or do this one on stream later. And then, hey, now we can actually do GPT-2. So yeah, hope that explains. NumPy 2.0 changes promotion as per NEP 50. Precision of scalars is now preserved consistently. Okay, cool. The higher precision of the scalar is not ignored. This can lead to lower precision results in running scalars, unless you may cast explicitly. Okay, cool. I think these are not currently problems for me, although now I'm curious about installing rough as a linter and if it works with VS Code. Default entry used by NumPy is now 64-bit. They didn't do this before. Okay. For historic reasons related to Python 2 is previously equivalent to the C long type. The default integer is now equivalent to np.intp. Most users should not be affected. Some operations will use more memory. Some operations may actually become faster. Libraries interfacing compiled code that are written in C, Python, or a similar language may require updating to accommodate user input using a long or equivalent type on the C side. Okay. C API changes. Some definitions were removed. Okay. I don't think I have to worry about this. Pyarray is now more opaque to allow us to add additional flags and have item size is not limited by the size of int. Code which only uses the type number and other initial fields is unaffected. Most code will hopefully maintain access to the element size field. I think element size. Cython code should use Cython 3, in which case the change is transparent. Okay. I hope I don't need this. Functionality to move to headers requiring import array. How does this... I think like one thing I'm wondering is like, how does this affect pandas? Like when is pandas going to switch over into NumPy 2? Or like NumPy 2 is a dependency. Complex types. NumPy, okay. Main namespace. Oh man, okay. I didn't even realize this is a function. I've always used all. There's no replacement as Python 2 is no longer supported. Okay. Deprecate. Array warp. Okay. Use np.nan. Okay. Oh, that's an interesting one. Table doesn't contain it means there's a private member. Okay. Lib namespace. Or namespace. ND array and scalar methods. Let's see. Okay. Ooh, okay. That's a... I think I have to refactor some code. If I upgrade to NumPy 2. Adapting changes. This is a lot of changes. It's just getting deeper into LLMs, kind of just a user of APIs at this point. You want to get into the weeds and learn how it works and map up. Perfect change, of course, to suggest for make mooring. Implement goldfish loss, retrain, and marvel. Yeah, Panda, that's a really cool idea. I take some time to get into LLM deving from scratch, but I'll get to it. I'm so slow now that there's like, I think, what's that really cool website that teaches a bunch of this for free? Free Code Camp. I think they actually have guides on like how to fine tune LLMs and stuff now, and I'm just like, oh, okay, well that's really helpful to know. But yeah. LLMs can memorize training data, causing copyright and privacy risks. Goldfish loss is a nifty trick for training an LLM without memorizing training data. I can train a 7 billion parameter model on the opening of Harry Potter for 100 gradient steps in a row, and the model still doesn't memorize. That's really important. Because the pace is going to be so slow, you can easily follow along, do your own projects, or just linger around and enjoy the spectacle. Yeah. It's like watching my streams where I'm trying to do GPT stuff is like, my guess is kind of like watching a train wreck through molasses. All right. Oh man, I restarted the kernel. I forgot. So where are we? Oh, I think I remember now. I was like, trill, wait, v out, p dot shape. Wait, okay. So the whole kernel, we have to run the entire thing again. Not right now. But yeah. What was I gonna say? Why do we need to train with goldfish brain when we can just have goldfish brain in real life? This is a really cool post. I kind of wish I was logged in so I could see the rest of this thread. See the prompt. Plus standard loss. The last being extremely more than anything. not regenerated. Okay, that's really cool. Goldfish loss for LLMs. Is it goldfish loss? Yeah. What the fuck is this dono bar? Oh, actually, I don't even remember anymore. Got that dog in me. Splitter. Wow, it's like, I don't remember what link I got it from. Somebody sent it to me, but it kind of, now there's like multiple knockoffs of it. Let's just go with this one. It's basically just this, because of course it's Costco hot dog related. Like I found another, like a knockoff of a knockoff, and it's like $20. So it's just like, oh, well, I could probably afford that one. But also, like, I feel definitely this is, I should maybe put a picture of what it's supposed to look like, and just put it next to that bar or something. But I think technically that link is like expired. I thought I put a timer on it, and it shouldn't even be there right now. It was supposed to like remove itself from my stream like at the end of February. It's been there for a really long time, and it's actually a little sad. But yeah, it might have been this one. I thought it was on Etsy. Like something like, look how many versions of it there are now. I did see someone at Costco wearing a Panic at the Costco shirt, and I thought it was awesome. But yeah. So you learned what sigmoid functions and logistic functions are today. You feel like that's the right math part to start out, and you're trying to dig into how they're implemented. Code. Oh yeah, that's really cool. That's a good idea. Oops. Be like a goldfish. Don't memorize. Mitigating memorization in generative LLMs. Archive link. We introduce some modification to the next token training objective that we call goldfish loss. During training, a randomly sampled subset of tokens are excluded from the loss computation. These drop tokens are not memorized by the model, which prevents verbatim reproduction of a complete chain of tokens from the training set. We run extensive experiments training billion-scale Llama 2 models, both pre-trained and trained from scratch, and demonstrate significant reductions in extractable memorization with little to no impact on downstream benchmarks. That's really cool. Okay. Never notices a quarter-pound plus. You know, they're really fighting to make sure that we get as much value out of that $1.50 as they can.
For the purposes of this single head between the different nodes. And that's basically the self-attention mechanism. This is what it does. There are a few notes that I would like to make about attention. Number one, attention is a communication mechanism. You can really think about it as a communication mechanism where you have a number of nodes in a directed graph where basically you have edges pointed between nodes like this. And what happens is every node has some vector of information, and it gets to aggregate information via a weighted sum from all of the nodes that point to it. And this is done in a data-dependent manner, so depending on whatever data is actually stored at each node at any point in time. Now, our graph doesn't look like this. Our graph has a different structure. We have 8 nodes because the block size is 8, and there's always 8 tokens. And the first node is only pointed to by itself. The second node is pointed to by the first node and itself, all the way up to the 8th node, which is pointed to by all the previous nodes and itself. And so that's the structure that our directed graph has, or happens to have, in an autoregressive sort of scenario like language modeling. But in principle, attention can be applied to any arbitrary directed graph, and it's just a communication mechanism between the nodes. The second note is that notice that there's no notion of space. So attention simply acts over like a set of vectors in this graph. And so by default, these nodes have no idea where they are positioned in the space. And that's why we need to encode them positionally and sort of give them some information that is anchored to a specific position so that they sort of know where they are. And this is different, than, for example, from convolution, because if you run, for example, a convolution operation over some input, there's a very specific sort of layout of the information in space, and the convolutional filters sort of act in space. And so it's not like inattention. Inattention is just a set of vectors out there in space. They communicate, and if you want them to have a notion of space, you need to specifically add it, which is what we've done when we calculated the relative.
Check a couple graphs on the paper.
And
Let me see. Let me see if this will load an Opera. Oh, hey, it did. No training, it's control, goldfish loss, standard loss. So pre-trained 7 billion parameter model is further trained for 100 epochs on left the first chapter of Harry Potter, or right 100 Wikipedia documents. We observe a drop in exact match memorization and Rouge L metrics. Oh, Rouge, okay, I think we heard about this before. I was like, wait, Rouge sounds really familiar. When training with goldfish loss, see section 4 for metric descriptions. When prompted with the opening of Harry Potter, the gray text, standard model regenerates the original text, which is in red, while the goldfish model does not. Ah. Quantifying memorization. Mitigating memorization. Learning without memorizing. LLMs are commonly trained using causal language modeling objective that represents the average log probability of a token conditioned on all previous tokens. For a sequence X set of xi of L training tokens, this is written as this. Okay. This objective is minimized when the model correctly predicts the sequence with high confidence. However, successful regeneration of a token at test time depends on the correct conditioning of the complete preceding sequence. This prevents the model from learning the entire token sequence. Choose a goldfish mask and define the goldfish loss as this. We ignore the loss on the ith token if its mask value is 0, and it includes the token if the mask value is 1. Most importantly, the outputs are still conditioned to all prior tokens, allowing the model to learn the full distribution of natural language over the course of training. We can simulate the impact of this intervention in a toy computation. Where, let's see, assume we are given, I was like, maybe I can skim ahead. I'm like, nah, assume we are given a model trained in a standard manner. For some memorized X from the training data and an integer M, sampling N tokens with prefix X less than M regenerates the string X less than M plus N perfect with probability P to the N. For P equals 0.999, N equals 256. This happens 77.4% of the time. I wonder how many of these people play gotcha games. Now assume that we were given a model trained with goldfish loss. Let's see. Now we regenerate n token perfect tokens probability p to the 2n over 3 times q to the n over 3. Q to the n of the 1/3. K equals 3, p equals 0.999, q equals 0.95. Sequence is sampled with probability only 1.06. Wow, okay, cool. Compounding effect of the dependence on sequence length n is critical. For example, for sequences of length n equals 16, the difference is only between 98.41% for standard loss to 75.26%. Okay, so this matters a lot with those like massive, like, hey, we stored like 4,000 tokens. Let's see, memorization as function of K and goldfish loss, control, L. Oh, excuse me. So this problem we propose to use a localized hashed mask. H cannot be too small, and the model may fail to memorize some important grams that should be memorized. Model may never learn to produce the word power at the end of Department of Water and Power. Can goldfish loss prevent memorization? Let's see. Benchmark performance. Pre-train 1 billion parameter models on 20 billion tokens as described in section 4.1. Evaluate downstream performance and various benchmarks. We know only marginal change in performance for models trained with goldfish loss. Red Pajama, not on Wikipedia documents. It is very simple, but seems effective. That's why I think it's a good follow-up on the Carpathy model. The first implementation sounds trivial, but then they have section 3.1. The one that we just read. That I was like, yeah, the first one doesn't sound that bad. And then it's like, okay, you're converting it to a hash is like, I think that maybe is not necessarily that difficult / hard, but it feels like, but I think their exact definition of how they're making the hash, I'm like, is this feels different than the last time I've seen like a hash mask or something like a hash whatever being used in like in the in that book I read about like data engineering practices. They're talking about like if you're dealing with NLP, they will do hashing so that's just like they can just store less tokens. And I think it's like they do like modulus 1,000 or what, something like that. And it's just like, oh, okay, that makes sense to me. But this feels a little bit different than that. I don't know why. Yeah. I'll prevent a small step for A memorization quote through kind of rotations of the same repeating text. Deep learning by Goodfellow, Bengio, and Corville is a good buy for building up your foundational knowledge. Is it? Wait, like... Let's see. Yeah, I was like, wait, like Joshua Bengio? I mean, it's probably pretty good. Is it free? Is it research intended to help students in the field of machine learning in general, deep learning in particular? Online version of the book is now complete and will remain available online for free. That's funny. This format is a sort of weak DRM required by a contract with the MIT Press intended to discourage unauthorized copying or editing of the book. Yeah, I mean, it seems good. And like Yasha Benjo is, and I think Goodfellow as well. I don't know who Aaron Corville is, but like I don't, because I'm not originally from computer science, like I don't recognize all these names. These two look familiar to me. So yeah, I would say this is a good one. DeepMind, okay. And Corville, University of Montreal. Okay, H index is 100. Holy fuck. What is Ian's 92? Jesus Christ. I feel like when I was in grad school, if you're H 236, I feel like when I was in grad school, if your H index was 6, it was like, wow, that's really good. Any material is good at starting point as long as you just keep going through it. Read deep. Yeah, I'd echo that. I mean, it's hard because like these names are very famous in this field, but that I feel like that doesn't necessarily guarantee that they're going to be the best educators, which is kind of sad. But I mean, it's free, and as long as you work through it, maybe you'll learn something that like, if you don't like how they approach a certain topic, you can probably find something from like Andrew Ng's course is really popular. Maybe if you combine it with like different angles on the same material, it might click better for you. Not saying that you won't understand it, but like sometimes even when I studied thermodynamics, like some of my books, I was just like, I don't like the way that they did this. And then I would like look at my professors would recommend like different textbooks. And when I looked at it from a different author's point of view, I was just like, this makes way more sense to me. But yeah, And the sooner you get away from reading into coding and experimenting, the faster you will learn. Yep. More thorough you learn, and the maths will make sense, and you get somewhere and you learn practical skills. Yeah. It feels intimidating. Like when I was going through all the documentation, trying to get BG M3 encodings or embeddings working, it felt intimidating because it was just like, okay, there's a lot of stuff. But it was also like, oh, I just like started messing around in VS Code. Like, oh, well, you can't read it right now. I just started messing around in VS Code. I'm like, all right, let me just try some stuff. And then it started working, and it was like each time like I didn't get an error message, it was like, okay, I'll just keep going. And then that's what made me late for dinner and stream. Goodfellow's not your average Goodfellow.
And added that information to the vectors. The next thing that I hope is very clear is that
What was the line? For as long as I can remember, I've always wanted to be a gangster. Is that the Goodfellow line? Ray Liotta. I think Ray Liotta passed, right? As far back as I can remember, I've always wanted to be a gangster. Always been a textbook first sort of learner. You're already a strong programmer in DB dev, so you could probably jump right in if you wanted to. Yeah. Yeah, I would give those a try, and then I think like deep learning AI. I'm sure they've got courses too. I think this is actually the group that has like Andrew Ng's courses. Oh hey, fine-tuning large language models, LangChain for LLM application development. Wow, I've never really looked at. I feel like I've always like directly gone into something like, yeah, I think like I went directly into whatever links. So yeah. Actually, let me from Panda. Deep learning book from Goodfellow, Bengio, and Corville. And it's free, so hey, why not? I mean, Intro to Stat Learning is always my refresher when I need to like look at applied machine learning or applied statistics. We're going to do exactly what Chrono's doing here, work through Carpathia episodes with work through meaning exactly that. Go through the video, keep Python notebook open, repeat every single line of code Carpy does, every example he gives. My only hesitation is like, Carpathia, like, we talked about this, I think 2 streams ago or last code stream. He pauses the video and then he's like, hey, so I refactored the entire notebook without recording it, and I just made it a script. And now we just import the script, and then we just keep going with the lecture. And I was just like, okay. That part I was kind of like, I don't know if I'll do that. I'll just follow along and then probably do this after. But it was like that was the, like, I've mentioned before when I had professors who would like write out all the equations, and then they're like, okay, but then this is actually, we need to make a modification, and then they just add the little like hat symbols over everything. And it's just like, professor, it took you 10 minutes to write all of that. It's gonna take us 10 minutes to write all of it again. But yeah, yeah, so I would say the deep learning book, and then also the like deeplearning.ai.
the elements across the batch dimension, which are independent examples, never talk to each other. They're always processed independently. And this is a batched matrix multiply that applies basically a matrix multiplication kind of in parallel across the batch dimension. So maybe it would be more accurate to say that in this analogy of a directed graph, we really have, because the batch size is 4, we really have 4 separate pools of 8 nodes, and those 8 nodes only talk to each other. But in total, there's like 32 nodes that are being processed. But
we'll update this. Attention is a communication mechanism. And I can do this. Oops. can be seen as nodes in a directed graph looking at each other and aggregating information. Did it again. Attention simply x over a set of vectors. Wow, it's already 10:18. This is why we need to positionally encode tokens. Example, across batch dimension is processed completely independently and never talk to each other.
There's sort of 4 separate pools of 8. You can look at it that way. The next note is that here in the case of language modeling, we have this specific structure of directed graph.
The text
where
just changed.
Tokens will not communicate to the past tokens. But this doesn't necessarily have to be the constraint in the general case. And in fact, in many cases, you may want to have all of the nodes talk to each other fully. So as an example, if you're doing sentiment analysis or something like that with a transformer, you might have a number of tokens, and you may want to have them all talk to each other fully, because later you are predicting, for example, the sentiment of the sentence. And so it's okay for these nodes to talk to each other. And so in those cases, you will use an encoder block of self-attention. And all it means that it's an encoder block is that you will delete this line of code, allowing all the nodes to completely talk to each other. What we're implementing here is sometimes called a decoder block. And it's called a decoder because it is sort of like
this over to math. Oh, cool, cool, cool. So for textbook learners, mathematical intro to deep learning. Can't believe we've gone for 2 hours already. That's wild.
decoding language, and it's got this autoregressive format where you have to mask what.
Okay, actually, since we're in an ad break, I'm gonna go get water. I'm quite thirsty. I'll be right back. Right, we are back. C Films, welcome in, welcome in. I am actually making some. I fed my sourdough starter, so I was gonna make some focaccia. Trying for tomorrow, but I think like it hasn't. It's in an awkward part where like. If I let it rise for another like 2 hours, I think it would be ready to start folding into some starter and some dough. However, the next step after that is like requires another like 3 hours of waiting essentially. So like I'm not doing that. So I'm trying to figure out like do I put it in the fridge and then take it out tomorrow morning, even though it's not quite done rising right now, or and what I decided was like I'll just leave it out for like another half hour, 45 minutes, and then see where it is, and then just put it in the fridge after that, and then I'll take it out like before I go to the gym, and I'll get going on the making the focaccia. Also probably means that like I'm seeing some people on Saturday, so I guess I have to like get another starter batch fed probably Wednesday or Thursday. The recipe actually calls for let me see. We're gonna do a little tangent. King Arthur baking sourdough focaccia. So the big one is like 19 hours and 40 minutes. So I'm joining people Saturday afternoon. So like I'm leaving like Saturday morning, right? Because I'm going up to the city. So there's like no fucking way I'm gonna be able to like do some of this stuff like day of. I'll probably bake it. I don't even know if I can bake it, right? Because like I have to cut it and then bring it with me. So yeah, we'll see. But like I guess I would have to start. So even if I bake it, I would have to start cover the panel in 14, 16 hours. So if I baked it morning of 30 minutes, this would be like an hour-ish. Okay, so it would have to start Friday evening. It'd have to start rising. Okay. And that means that if I actually remember to do this stuff, I would probably have to feed it Friday morning. Really early Friday morning. Oh, leg day. Okay, I think I will do the same thing. I'll get it ready Thursday night and then just put it in the fridge. And then hopefully it'll be still ripe and stuff Friday morning. Just let it come up to temperature. And I definitely need to go buy some more bread flour. Yeah, so if you are working on your own sourdough starter, this is actually one of my favorite recipes. It's always a hit. Every time I made it, it's been a hit. And I don't even think I make it that well. Like my focaccia usually doesn't have those like nice bubbles that you usually get in the crust or the crumb. It's kind of dense, but like it tastes good and people seem to really like it. So hey, can't complain.
Or matrix, so that nodes from the future never talk to the past, because they would give away the answer. And so basically, in encoder blocks, you would delete this, allow all the nodes to talk. In decoder blocks, this will always be present, so that you have this triangular structure. But both are allowed, and attention doesn't care. Attention supports arbitrary connectivity between nodes. The next thing I wanted to comment on is you keep hearing me say attention, self-attention, etc. There's actually also something called cross-attention. What is the difference? So basically, the reason this attention is self-attention is because the keys, queries, and the values are all coming from the same source, from X. So the same source X produces keys, queries, and values. So these nodes are self-attending. But in principle, attention is much more general than that. So for example, in encoder-decoder transformers, you can have a case where the queries are produced from X, but the keys and the values come from a whole separate external source, and sometimes from encoder blocks that encode some context that we'd like to condition on. And so the keys and the values will actually come from a whole separate source. Those are nodes on the side, and here we're just producing queries.
Weaker legs.
Off information from the side. So cross-attention is used when there's a separate
I hate leg day.
nodes we'd like to pull information from.
Give me entirely less.
And it's self-attention if we just have nodes that would like to look at each other and talk to each other. So this attention here happens
I
to
was
be
sore until
but in principle,
Sunday evening. from
It also
Friday's
is a lot
leg
more pro.
day because I
And the
hadn't.
last note at this stage
I took
is,
like a week
if we come
off.
to the attention is all you need paper here, we've already implemented attention. So given query key and value, we've multiplied the query and
Actually, look
we've
for
softmaxed it, and then
the
we are
best thing
aggregating the
about leg
values.
day is
And
that
there's one more thing
I
noticing here, which is
allow
that divided
myself
by
to
1 over
break my
square root of the head
intermittent
size,
fast because
we gain
otherwise,
the
like,
head
I'm
size.
dying
Why
by
are we doing this?
like
Why is this important?
lunch, and
So
like
we
the
call it a scale
the lactic
of
acid
energy.
stuff doesn't clear
And
out or
I've input
anything, and I
normalization
just
to
feel
this
like I
here.
don't have enough
The
food.
problem is if you have unit Gaussian inputs, so 0
So
meaning
like
unit
I have
variables,
a
K and Q are unit Gaussian, and
breakfast
if you just do
after
weight
leg day.
natively, then you see that your weight actually will
But
be,
I feel like
the
what's
variance
really
will be 1
bad
over
is
head
that
size,
my
so that
current
equals to 16.
routine also has
But
me
if
do
you multiply
bench
by 1 over head size
like
square root, so
on
this is square root,
some
it's 1 over,
weeks. So like I'll
then
be
the
exhausted
variance of
from
weight
doing
will be 1
legs, and
to
then I'll
preserve.
like finish out by
Now
doing
why is this
abs, and
important?
then I look at my
You'll notice that
spreadsheet
weight
and it's
here
just like
will
I
fit
have to
into
bench
softmax.
max reps
And
until
so it's really
failure.
important, especially
Cool,
at
cool,
initialization,
cool, cool.
that weight be fairly diffuse. So in our case here, we sort of blacked out here and weight at a fairly diffuse numbers here. So like this. Now the problem is that because of softmax, if weight takes on very positive and very negative numbers inside it, softmax will actually converge towards one-hot vectors. And so I can illustrate that here. Say we are applying softmax to a tensor of values that are very close to 0, then we're going to get a diffuse thing out of softmax. But the moment I take the exact same thing and I start sharpening it, making it bigger by multiplying these numbers by 8, for example, you'll see that the softmax will start to sharpen. And in fact, it will sharpen towards the max. So it will sharpen towards whatever number here is the highest. And so basically we don't want these values to be too extreme, especially at initialization. Otherwise softmax will be way too peaky. And you're basically aggregating information from like a single node. Every
Thanks,
node is aggregating
Malware
information
Bytes.
from a single other node. That's not what we want, especially at initialization. And so the scaling is used just to control the variance at initialization. Okay, so having said all that, let's now take our self-attention knowledge and let's take it for a spin. So here in the code, I created this head module and implements a single head of self-attention. So you give it a head size, and then here it creates the key, query, and the value linear layers. Typically people don't use biases in these. So those are the linear projections that we're going to apply to all of our nodes. Now here,
I think didn't we write this class in here? Class head. Okay, so we have to write all this. And I know it's better in the... I didn't get to finish the other notes he was talking about. I know it's better in a script, but I want to stay inside the, what's it called? Notebook for now. Then I have to like re-import everything. Def, and then I can just copy paste it into a script later. Head size super dot init key equals dot linear and bed head size bias equals false. I really feel like I wrote this bias equals false. I did, but not quite how I expected it to be. Self.query. Up and bed, which is not defined, and then self.value. Same thing here, and embed. Self.register buffer. Trill. Torch.trill. Torch.ones. Block size. Block size. Cool. Alright, def board self x. And we have and weights equals these. heck? What did I... Why didn't that copy paste? That was weird. There we go. Return out. Okay. BTC, C, B, self.key. Self.query. B, T, and C equals X.shape. Let's see. Compute attention scores affinities. Weights is Q matrix multiplied K dot transpose minus 2 minus 1 times C to the minus 0.5. This is C B C T. And that should be BTT. Okay, cool. It's at max fill. So it'd be self dot trill. This is colon T slice up to T, and this all equals 0. And it's the same dimensions. BTT. And this is f.softmax. Wait, Tim. Okay. Well. Okay. Perform the weighted integration of the values. Self dot value of x. This is BTC. I think this is what you're talking about, Hitos, of like going back and like enforcing some type of dimensionality. BTT, making sure that you have all the right dimensions as makes sense. Oops. TC. Turn out.
Creating this trill variable. Trill is not a parameter of the module. So in sort of PyTorch naming conventions...
Oh, let me catch up on chat. Let's see. How's learning going? How's job hunt going? Well, I took a vacation. I feel very recharged, so positive about coming back. I think the vacation also helped me kind of realize like there's a lot of stuff in life that isn't just looking for a job. Like seeing my friends with their kids, and then also hearing about different friends who went through similar experiences as me, were like getting laid off and having trouble finding a job, and how long it can take. Even in like, especially in down markets and stuff. And it just kind of like maybe helped me put things in perspective of like, things are going to be okay. You like, don't give up, but things are going to be okay eventually. And like, frankly, there's just like, things are just more important than like whatever job. Like they're fucking kids, right? Like they're great. So yeah. Ask me in a few months or whatever if I still haven't found anything, and see how if I still have like a positive attitude about stuff in general. But like I'm feeling pretty good right now. And learning stuff is like, I don't know, the recharge has meant that like I'm excited to like go back and like go through stuff. But yeah, although today I like looked at the list of jobs that I wanted to apply to. I'm like, I still have to whittle those down. So yeah. What do you think about these results for an open weights model? Interesting. Why can't I just highlight the one line? Come on. Oh my god. Okay, cool. Both in Carpe sessions as well as real. Yeah. Let's see. And then Melion, not much has happened. I'm still working, still trying to focus on like back end stuff, and like I really want to make these new embeddings and then refactor so that I can maybe instead of having the website be live and testing, that's where I'm doing all this stuff. I want to refactor so I can just run it in a notebook and make it a little bit quicker and dirtier. And just be like, hey, this is the recipe you search for. This is actually how it works in the back end, kind of. I can demonstrate it on stream. And then just like, kind of like, it would also help me figure out how sorry, I just think it's funny that the text got cut off and it says asshead. I'm a child. But I figure if I refactor so it's a notebook, it makes it easier for me to like do, get a sense of how I want some of the responses to go, especially if it's like, hey, I'm reviewing how this search was. A user may not see the same thing, right? Like I probably don't want to ask a user the same questions that I ask because it does take a while, right? And I try to value that if someone uses Meal, I want to value their time and help them like basically just like suggest recipe and let them try to make it. I don't want them to like go through this whole like, how would you judge the interestingness of this recipe? Vacation definitely did good for me. Oh yeah, thanks. I mean, I'm not tan or anything, but you know, a few months you'll have to start reproducing, making some kids on your own just to preserve sanity. I mean, like, that's definitely my parents maybe were like, hey, so maybe you should start dating too. And I'm like, yeah, cool. I'll just I mean, like, hey, Adventure 3, welcome in. Thank you for the follow. Thank you. A little bit like salty. Like I matched with someone on a dating app before my vacation, and we're kind of chatting about stuff. And there, you know, life was busy for both of us for different reasons. And then I come back from vacation. I'm like, hey, so like, how are you doing? It wasn't that long. It was like a week, right? Since the last time I talked to them or to her. And she did say like, I started dating someone already. I was like, okay, that's fine. We didn't really know each other that well, but it was also like a big surprise to me where it's just like, I thought we set up a boundary and then all of a sudden you just kind of broke it. But it's just like, okay, whatever. I'll find someone else that's cool. But I don't know. I did say like, you know, we really didn't know each other that well, so I'm still open to like at least like having some sort of friendship, but it did feel a little bit like that was a little bit of a betrayal. I think I did see something like this. Was it in what's it called? Was it in AI News? Where it's like significantly cheaper cost to run. Was it this one? Yeah, okay. I thought this was really cool. So I just think that the cost is great, right? Because like this means that people can try a bunch of stuff and it just makes it easier. 230 billion parameters, holy shit. 338 programming languages and 128k context length. I actually really wonder about that, like that goldfish memory with the context length this long. Like how I really wonder what will happen with that. But I don't know. I think this is really cool. Per million input tokens. It's so much cheaper. Like cheaper than like what are the big ones that people care about? Like GPT-4 Turbo, Claude 3 Opus, that like high-end one. The Llama 3 70B and Llama 3 13 billion. Is it even on here? Or is it even a 13 billion? Maybe mixing with like a smaller Mixtral or something. Like it's really cool that it's so cheap or inexpensive. This is an open model and up there right in the big leagues of the best commercial. Yeah, this is very cool. It's this one. So hold on. In the news here, it's focused on. Oh, okay. Never mind. This is a separate thing. I miscombined stuff. So like DeepSeek Coder v2 is different from DeepSeek v2. So DeepSeek Coder v2 may have something else with it. Wow, that's cool. What did they train on? Collect code data from GitHub and apply the same filtering rules as star coder data to filter data. Interesting. Okay. Model training, 10% coder language, GitHub Markdown, and Stack Exchange. 3% related non-code related Chinese language. I'm kind of wondering, so like Stack Overflow had the users revolted, right? Because like Stack Overflow started licensing the user generated data to what, like, was it OpenAI, for better code response stuff. And so this is from GitHub. Do all of our repositories on GitHub, are they just like allowed to be part of this? Because like one, it's like, oh wow, that's I don't remember reading that in any of the terms of service or whatever, but like how much do I remember? I have goldfish memory, right? And two, like, man, my code isn't that good, right? So like if you trained on that, it's just like, I'm sorry. I'm gonna ask GPT, or sorry, ask a DeepSeek, like, what would you call a recipe recommender? If it says Melion, I'll be like, hey, what the hell? Massive training data, 2 terabytes set in GitHub. No one ever says what's included in. Yeah, I feel like that's like, I would have thought that since this is an open source one, that they would just be more like transparent about it. DeepSeek Coder v2. Mixture of experts language model. 40. Oh, that's really cheap. 8.1 trillion tokens. Due to the constraints of Hugging Face, open source code currently experiences slower performance than our internal code base and running on GPUs with Hugging Face. We offer a dedicated VLLM solution that optimizes the performance of running our model effectively. 236 billion parameters. Oh, I read that before, actually. Mixture of agents to squeeze out more value from less state-of-the-art open source LLMs. Oh, let me save these. In stream notes. Introduce a mixture of agents, an approach to harness the collective strengths of multiple LLMs to improve state-of-the-art quality. Alpaca eval, surpassing prior leader GPT 4.0. Our research is based on a key observation we term the collaborativeness of LLMs, the phenomenon where an LLM tends to generate better responses when presented with outputs from other models, even if these other models are less capable on their own. That's cool. Single model with response. Wow. Categorize roles based on their strengths in different aspects of collaboration. Proposers and aggregators. I wonder why this is. Like, part of me wonders if it's like, so it generates responses. And one of the things I've been wondering lately is like, if we don't need that many tokens, if you summarize a response and use that as a feed for something else, does that make it better? Because it kind of like, the summary, if it does a good job, is like picking out the very important words / tokens. And I guess that just feeds into whatever the next model is. Fine-grained evaluation of multiple dimensions. Harmlessness, robustness, correctness, efficiency, factuality, common sense, insightfulness, and completeness. Together, Mixture of agents also outperforms GPT-4o in terms of correctness, factuality, sentence completeness, and metacognition. Okay. Cool. Do we need multiple layers? Aggregator is sophisticatedly synthesizing rather than just picking and selecting. Do we need multiple LLMs as proposers? To know n is the number. Clearly a consistent advantage brought by having more proposer outputs even with single proposer. Multiple proposer configuration consistently outperforms single proposer. Wider variety of inputs from different models significantly enhance the output. Interesting. Okay. So there's kind of a drop off. Let's see. We're looking at. The only we also had a baseline aggregators. Okay. I guess it's still going up, but kind of like, I mean, if you did the elbow method, you're probably good at like 2 or 3 layers. I mean, I don't know how much slower it is to have multiple or more. Let's see. Cost effectiveness. Calculate the price using data from Together API. Pareto front, indicating the most optimal balance in cost and performance. If we aim to strike a good balance in quality and cost, the Together MOA Lite configuration can match GPT-4o costs while achieving higher quality. Okay. It's pretty cool. Shared contributions of Meta AI, Mistral AI, Microsoft, Alibaba Cloud, and Databricks. Oh, I forgot. Yeah, they had their own model, DBRX. Best and cheap. We're going to deny that. Auto-mounted. So let's time out. Well, already that name was already gone, so I can't do anything. But, you know, if that person posts again, we know what's going to happen. Yeah, okay, cool. All right, let's go back to... We're not going to be able to finish this video today either.
It's not a parameter, and you have to call it. You have to assign it to the module using a register.
Yeah, that was a cool link.
So that creates the trill.
Both cool links.
Lower triangular matrix. And when we're given the input x, this should look very familiar now. We calculate the keys, the queries. We calculate the attention scores inside way. We normalize it, so we're using scaled attention here. Then we make sure that future doesn't communicate with the past, so this makes it a decoder block. And then softmax, and then aggregate the value and output. Then here in the language model, I'm creating a head in the constructor, and I'm calling it self-attention head. And the head size, I'm going to keep as the same and embed.
Okay, let me scroll back up to the... Oh, not this site. Gram... Language. Okay. We have the inits. This is going to change. Self.position embedding. Embedding table. Oh, wait. This is a bigger refactor than I thought. Okay. I just have this in separate cell, which is not a practice actually. Like, inits. We actually don't need vocab size anymore. Super init. Which directly reads off the logits. The next token from a lookup table. Okay, cool. That's fine. Self.token.embedding table. Self.token. Sorry, position. Embedding table. And embedding. Block size. And embed. Self.sa head. Head and embed self.lm lead head, not lead, and then dot linear and embed vocab size. let's see, def forward self IDX targets equals none. Okay, cool. IDX, oh, we need new line here. ET equals IDX dot shape. Cool. Let's see. Logits. IDX and targets are both BT tensors of integers. We can kick this down. Token embed equals self dot token embedding table IDX BTC pause embed equals self dot position embedding table torch dot a range T device equals device no 0 and then this is TC then X equals toke embed plus pause embed and that should be dimension BTC and then X equals self dot SA head X and then apply one head of self attention BTC and then we have logits equals self.lm head. X. An AI can drop any AI related stuff from my spot on. Oh, nice. Yeah, yeah. Hopefully I'll be able to figure it all out one day. I am studying building GPT from scratch. We're very slowly going through this class. Like you notice it's like a there's a link to the video. It's like a 2-hour lecture and I've taken multiple 2-hour streams to try to finish this. Just a little slow, we get distracted, but you know, we're trying to learn and it's cool. Let's see, def.forward. Okay, I did that.
Just for now. And then here, once we've encoded the information with the token embeddings and the position embeddings, we're simply going to feed it into the self-attention head, and then the output of that is going to go into
This is the same.
The decoder,
That's the same.
and create the logits. So this is sort of the simplest way to plug in the self-attention component into our
Yeah, and actually like
I had to make one more change.
probably end in like
which
5
is
minutes.
that here.
So maybe we'll finish this code block, then I will go get ready for bed because I did not sleep super well last night. And then yesterday I was actually like dizzy for most of the day, so it was just not a fun day. I don't know what it was. I think I just like haven't been sleeping super well. Last night I woke up like 3 hours into my sleep and I was just like, what happened? Why? And I thought it'd be fine. And then I woke up for real and it was just like, I don't feel 100% and I am tired. To the last block size tokens. IDX cond equals IDX. One is block size. With the predictions, this would be self IDX cond. Logis loss. Focus only on the last time step. Okay, cool. And that's probably all the same.
Here, in the generate, we have to make sure that our IDX that we feed into the model, because now we're using positional embeddings, we can never have more than block size coming in, because if IDX is more than block size, then our position embedding table is going to run out of scope because it only has embeddings for up to block size. And so therefore I added some code here to crop the context that we're going to feed into self, so that we never pass in more than block size elements. So those are the changes, and let's now train the network. Okay, so I also came up to the script here, and I decreased the learning rate because the self-attention can tolerate very, very high learning rates. And then I also increased the number of iterations.
Okay, so that code is the same. And then, let's see, hyperparameters. Batch size equals 32. How many independent sequences will we process in parallel? block size equals 8. What is the maximum context length? Or predictions? Max iters equals 5,000. Eval interval equals 500. Learning rate is 1e minus 3. Device equals CUDA. If torch.cuda.is available, else CPU. Eval iters is 200. N embed plus 32.
Because the learning rate is lower. And then I trained it, and previously we were only able to get to up to 2.5, and now we are down to 2.
Been busy and distracted lately, so you've not done much work on the C Films website. Yeah, hey, life happens. Hopefully you're not too down about it. But yeah, I mean, you're thinking about picking it back up again soon? You're quite weak in gym hits house. I guess it's the same thing. Are you picking that up too? My walking has gone down a lot. Like, I didn't realize like my step target is 15,000, like 15,500. That is my minimum number of steps. Like, that's basically what I want to do as a minimum. And my like hard limit where like if I hit this number, I'm just like, just sit down. Just like don't walk around for the rest of the day. Maybe like walk around a little bit, but like don't think about actually taking steps. My like that cap is 18,500. And when I was visiting my friends, like it was actually kind of a struggle to hit like 5,000 steps. And I was just like, wow, I take like a lot more steps than normal people. Like because of reunion, we're like walking all over campus and it was like relatively easy to hit 10,000, but I was still like, I'm like way short on what I want to be doing. You beat 40% of your age group in 10 reps soon in deadlift and bench press and 30% squatting. Hey, then you up the goal another 5%. Hey, I mean, just don't get injured because it sucks when you get injured. But yeah, that's really cool. I'm thinking about getting chalk, like liquid chalk for my hands because like one of the regulars at my gym, like he noticed, he was like, hey, I noticed that like sometimes it looks like your grip gives out before your deadlift does. And I was like, oh, I guess, yeah. And he's like, here. And then he put liquid chalk on my hands and he was like, you can just get it on Amazon, it's really cheap. I was super strong. That like I think I struggled on that, like I was doing 3 sets of 6 or something. And I've been struggling with it, and then he gave me the liquid chalk, and I just did it easy. And it was just I didn't even have to like. Normally, when I'm doing deadlift, I'll start overhand grip, and then when I feel like my grip is giving out, I swap. So I'll do like a mixed grip, and then I try to divide it so I do like an equal number of reps in mixed grip on both sides. But when he gave me the liquid chalk, it was just like I didn't have to switch at all. It was great. I felt very strong. So I'm kind of like, I don't need that. It would be nice to have it. It's really just stupid for pride. Like my own sense of pride.
2.4. So we definitely see a little bit of improvement from 2.5 to 2.4 roughly, but the text is still not.
There's no feeling of injury
So
approaching.
clearly the
Being weak
self-sufficient
protects
has
you.
been
You'll never
some
load up.
useful communication,
Oh, yeah, that was
but,
definitely my problem.
We still have a long way to go. Okay, so now we've implemented the scaled up product attention. Now next up in the attention.
Okay, oh wow, we're at 2 hours and 45 minutes. We're past my 11 o'clock cutoff time before I'm like, I should go to bed. So let's go find someone to raid. We'll try to finish this up. Tomorrow is friend streaming. So not streaming video games. So I will not be streaming data science stuff tomorrow. Maybe if I change my mind, then I'll come on earlier in the day and I'll just be like, hey, surprise, we're gonna go finish this class because it's been forever. But who knows? Usually I'm like studying during the day, so I'm like, okay, I don't want to necessarily stream. Let's see, Griffin and Chill is on, but that's not data science stuff. Awarahun is doing Leak Code. Arya is on. Oh, Arya is on. Let's raid Arya. It's been a while. How long can I hang with one hand? I've literally never tried that. And it's one of those that, like, when I used to climb, my climbing friends were like, just do a dead hang. And I, having never done that, I was like, oh, this is actually really hard. Like, I think my longest dead hang is like 30 seconds. Maybe 90. And it was like, at the time I was doing 30 pull-ups. Like, just one set, really easy, 30 pull-ups. And then I was just like, literally just don't move. Just hang there. I was just like, holy crap, this is so hard. Alright. So yeah, raid Aria ADM, and then we'll put this in stream notes too. We raided Aria ADM. What the heck? So I have fans on, one fan behind me and my ceiling fan. And I don't know what happened. Like, my AC should have been on this whole night and it wasn't even that hot. But it feels like it got colder, like noticeably like cooler, just in the past like couple minutes. Maybe because I'm not like stressing about trying to be as smart as Andre Karpathy. Because I'm like, oh, I'm going to bed. But yeah. Okay, so we're rating Aria. Thank all of you for coming in today. Schedule wise, what do we got? Tomorrow, very likely no stream like normal. Wednesday I should be on, and hopefully I'll be on earlier like I should be. Thursday will also be on, both days data science stuff, and then Friday I'll be on doing data science stuff. The other stuff I'm doing off stream is trying to clean up a little and like do some cooking and stuff. Maybe one day for Friday we'll do like an art stream slash like we'll just like chill out in the kitchen and while I'm trying to cook something. So I don't know. I think it'll be really boring to try to stream that, like making focaccia this week, because I'm not going to be. It's literally just mixing stuff and then waiting, right? So it's like, and then I can't even type, right? Because my hand will be covered with the dough.